At the top of this page, it has a little reminder about words in probability and how they change. So, for example, at least really means greater than or equal to. More than means or greater than, so they both mean just plain greater than. Less than. At most, remember, at most means less than or equal to. All right, so a report from the Secretary of Health and Human Services stated that 70% of single vehicle traffic fatalities that occur at nights or on weekends involve an intoxicated driver. If a sample of 15 single traffic fatalities that occur at night on a weekend is selected, find the probability that exactly 12 will involve a driver who is intoxicated. Okay, so the way we're going to do this is binomial dist, and we're going to say, okay, you have 12 successes. Not that being killed by a drunk driver is a success, right? Don't get me wrong. Success, failure is not necessarily words that mean what we think they mean in English. It's that success means what you were looking for your binomial probability. But of course, it might be a very bad thing indeed, as this would be. And then it's going to want the, actually, I can't remember. Let's go back to Excel and look at it. Make a new page. Okay, so binomial dist, or you could use the dot dist if you have 2010 like I do. Again, it was 12 successes. The number of trials, which would be the number of traffic fatality accidents you were looking at, which is 15. The probability that involves a drunk driver, according to the Secretary of Health and Human Services, is 70%. So 0.70 false, because we want an exact probability. When they want exact ones, you always say false. Okay. Oopsie. Copy. Paste. Which is, what was it? 0.17044. There we go. That's that probability. Now the next one said, public opinion reported that 5% of Americans are afraid of being alone in the house at night. If a random sample of 20 Americans is selected, find the probability that. All right, let me bring Excel up side by side here so we can do these together. All right, so let's think about this. Equals binomial dist. Okay, now how many successes do I want? I want a probability that there are exactly 5 people in the sample who are afraid. So I want 5 people that are successful in being afraid out of the 20 that I pulled. The probability of success is 0.05. And this is false because it's an exact probability. So there you go. And I'm going to write out what I typed as well, because I think it's important in the notes to have kind of a sense of what I was doing, and you should do it too. All right. Now, what about the probability that at least 3 people in the sample are afraid of being alone? All right, now here's where it gets tricky. So let me do this a different way. So number afraid, we could have 0, 1, 2, all the way up through, I'm going to have to make this smaller so you can see, 20. Hold on. There we go. Oops, one more. All right, cool. Let me scroll down so you can see it. Okay, so there's the number afraid. And then now I could have the probability. And that would be equal to binomial dist, or binomial dot dist, that cell A2 out of 20, 0.05, false. And by the way, there are a couple ways you can do this. This is just one way that I'm thinking of off the top of my head. All right, so when they want the probability that at least 3 are afraid, what they really want is all of these. There's so many of them, I can't even get it with my mouse. They want those. So what you can do is you can find these 3 up here. I'm going to make them pink. Pink. Find those 3, add them up, and take it away from 1, and you'll have it. So equals sum of these 3 equals 1 minus that, and that's the answer we were actually looking for. So it's 0.07548. All right, that's how to find that one.